do you really need to train a neural network from scratch every time? So what if your dataset is too small to train deep learning model properly? Why spend days, maybe months training when someone already trained a powerful model on millions of images? Is the isn't there a smarter way, let's say, to reuse the existing knowledge like we do in our real life? What if your model couldn't remember how to recognize shapes, texture, or objects before even see your data? So if you have any question of the ask yourself questions about this. So welcome to transfer learning. So it's how modern AI system learn once and apply everywhere. It's like a musician who learns one instrument and then pick up other, let's see, faster. So let me now talk about the, let's see, the objective of this lesson here. So as you can see, transfer learning is learning once apply elsewhere. So we will see how the what is the transfer learning, what are the main components of the transfer learning, and when not to use the transfer learning, and what are the popular, let's see, framework. So as you can see in this image here, this is the ResNet ResNet 18 architecture, and this trained on an ImageNet with a huge number of images, millions of images. So could we use this, let's see, as it is as a trained model, and use it for our, let's say, data? The answer is yes, but we need to know how to use it. And as you can see here, this ResNet, it was trained on ImageNet, and it has 11, it's almost 12 millions parameters. And the number of layers, it has 18 layers and 17 convolutional, and one fully connected layer. And the input size is 224 by 224. So as you can see, this is it used the main features of the ResNet. It used a residual connection and max pooling. And residual connection, I will try to make a video on this because I haven't done this before. And it was the winner in 2015. So as I said in the beginning, imagine this, for instance, the trained model, the pre-trained model, and has image data, and this is the hidden layers, let's see, extracting the features, and this is the classes to classify the images, or to classify any type of data. So this is let's see, a connected fully connected layer, but just as example. So because ResNet, it's use a convolutional neural network, not like this. And just to see to show you the principle of the transfer learning. The transfer learning, as you can see, I will use the same architecture, but with different classes. As you can see here, I have, where's the classes? Okay, maybe it's removed. I don't know why. So I have two different classes. Let me just see why it's not there. Yeah, it's, as you can see here. Let's just as example, I have used this pre-trained model as the number, the input size. Let's see, has to be the same. The hidden layers must, I mean, even at least the first layers has to be exactly the same. And you can see, for instance, the last layer here is updated. So this, I have only three classes. So I can adapt the pre-trained model and use it for my new task. So this is how the transfer learning. This is answering question, can I use the pre-trained on my data set? Yes, with transfer learning. So why using the transfer learning? Transfer learning is saving much time. So instead of train your model on a huge number of images, and you need also, I mean, from scratch, and also you need a lot of time, a lot of data, and also resources. And if you have small data set, you won't be able to use the neural network. You can use transfer learning. So sometimes you have only a small data set. So this is a perfect for your data set. and also better performance. Sometimes, if you use a transfer learning, you will get a perfect result, or let's say satisfied result, even with training with few epochs, let's say 3, 10, 5. It depends on your data. And what are the components of the transfer learning? You have the pre-trained model, which is a model that trained on a millions of images, and it took for the training, it took several days, several weeks even. And the second one is this pre-trained model is used as a feature extraction, and the new model will be only updated the head of the classifier. As you see, as you see here, it's removed again. As you see, this is the same architecture but different classes. And this part here is called fine tuning. And as you see, the previous layers, let's say the first some layers have to be frozen. It means no update during the training. Only this part should be updated. And the popular frameworks could be TensorFlow, PyTorch, and Hugging Face for NLP. So for today, I will use PyTorch. And when you would like to use transfer learning, or when should you use transfer learning? When you have a small data set and you have no resources and you have, let's say, no time to train the model from scratch, so you should use transfer learning. And try to avoid transfer learning when you have a big data set and completely different from the trained model. So let me just show you one example. ImageNet. It was trained on such images, on animals, on human, cars, many classes. And let's see if you see industrial, let's see defect detection. Let's see have to have a data set. So as you can see here, this is different features, different shapes, different appearance. So I'm trying just to tell you that it might be work, but try to, if you have a different data set from this, you can see here, it's a different data set, right? And the features of everything is different. And if you have a different data set, try to train it from the scratch and try to only use the one that is somehow relevant to yours. And you can see your task is completely different from the pre-trained, and this one is a different task, this one here. And the data set, if you have a big data set, try to just use your own model. You might be using the ResNet. Where's the ResNet? You could use the ResNet network, but you need to update the whole weights. I mean, use it as it is, and for each layer, you don't need to freeze the layer, the weights. You need to update everything here. So now let me just show you how we can do this in a PyTorch. Okay, so let's start. So here, this is the Jupyter notebook, and you can see I have the transfer learning. I will try to import the libraries, transfer for pre-processing the images, and also loading the data with 10 classes, let's see, and loading the pre-trained model, which is ResNet in our case, ResNet 18. You can, of course, you have the choice to choose whatever you want. There are many pre-trained model I will show you. And we need a function to calculate the parameters, and also freezing the layers of the trained model. So to save time, we need to freeze the layers, some layers, and we need to, oh, sorry, oops. We need to modify our classifier and then training the model. So let's start from this. So we need to import torch, import torch Torch Vision. This Torch Vision has the models and also the data sets, and of course also the transformers. Let's see, transformers, input transformers as transformers. You can use it, or maybe you can also use it as choose whatever you want the name. This is fine. And import torch dot nn as nn. This will be used to update the pre-trained model and updating our, let's see, new classifier. Now we might also need numpy as nb, and we also need importing from torch, from torch we need, yeah, before this. So after importing the torch, I mean the nn, we need to import the optimizer from torch dot optimizer import import name. Let's see, as optimizer. And now we might need the models from torch dot from torch vision import models. And you can see here, if we click on this, you can see this is the OD pre-trained models, and under each category you have many let's see, versions. So if you jump just to ResNet, you can see ResNet 18 with ResNet 15, ResNet, and it has many ResNet, and we will use, let's see, for this, for example, this one here. And you can just even use with MobileNet. You can use MobileNet, and you can use whatever you want from version here. So as I mean, you can use it with a transfer learning. And now we might need to the device to check if we have torch.device. Yes. So the device should be coda if torch dot coda dot is available. If it's available, else use a CPU. So if you see, now let's print the device. Let's a CPU because I have no GPU in this device. Okay, now we have the transform. We need to transform. Is equal to transforms dot compose. This is used for the pre-processing the images. So once we have the images, it will try, let's see, let me remove this. It will try to, let's see, I need to transpose dot resize the image. Okay, and resizing the image, I need 224 because the input of the ResNet 18 is 224. Now we need also to convert it transforms dot to tensor. There's no parameter here, and also we need transforms dot normalize. We need to normalize the image, and we have the mean. Let's see, just let's see 0.5, 0.5, 0.5. It's fine. But for this, you need to see the ImageNet. Let's see transformation. Just to see why, because it's taking the mean and standard diffusion of the whole images in this dataset. So, and let's see, just copy this and use it here. And this is the only the transformer. Of course, you need to change also this the mean, but it's just fine. You know how to do it. So let's see, run this. It has nothing to do. So now we need a data set. So train set is equal torch dot torch vision, indeed torch vision dot data sets. Which data set we would like to use? We would like to use this one here with 10 classes. And root is equal data, and see if the, let's see, trained is true, we need to use it for the training, and also download is equal also true. If it's not there in the directory, it should be transform is equal transform, it equal this one here. We need to transform these images. So we will download the images, I mean download the data set, and the transforms will be used as we have done it here. Okay, so I think the parameters are enough for that. Yeah, and I just copy this this 3 lines, and it's taking the first 2000 images as the trained images, and it will be in the train loader, and each batch file has 32 images, and the shuffle is true. So it means every, let's say, every ebook we will have a different images, batch images. Let's see, now we need to generate to get our model. So we have imported models dot resnet. We need 18. Now this should be enough, and we could also print the model dot parameters. So let's try this first. Run. Okay, it will try to download the whole images, the dataset. This might take few minutes. I will pause the video. Okay, finished. Oh. So this is our model. I will see. You can see this is the ResNet parameter, ResNet 18, and you can see it has, let's see, four blocks, but called the layers, layer 1 and layer 2 and layer 4 till layer 4. And you can see the fully connected layers at the end of the layers. The input is 512, and the output, let's see, the number of classes will be 1000. And for this we need just to update this part here, and the whole part from here should be the same, and also including the weight. Now let's write a function to download, to calculate the parameters. Count parameters. model def total parameters is equal sum of p dot model, not model. Let me just copy this because it's yeah, I have copied. I can't memorize everything indeed. So this is the parameter. Here you will load the parameter, and for this parameter you will try to sum up number of elements, and the trainable parameters will be true. Let's see, sum of the trainable parameters if the requires gradient is true, and you'll have total number of features, total number of parameters, and the trainable parameters. And if we see, let's see, just run this function, and let's try to print, let's see, final layer. You can see model dot fully connected. We also need to print number of parameters, or maybe also a number of classes. We see model dot fully connected layer dot out features. You can see in this is the out features, and we might also need the parameters. Let's see, this calling this is equal count parameters. The input should be a model, and we need to print number of parameters. Let's see, total params, we also need to trainable parameters, So if you see, the final layer is 512, and number of feature, let's see, classes is 1000, and total number of parameters is this one here. It's 11 millions parameters. It's almost 12, not 12 millions parameters, almost. Now we need to freeze these layers. So let's see, for we need to param, this is fine, I think, in model dot parameters, param dot require requires gradient. It should be this. I don't know why it's not showing. Is equal false, and let's try model. Oh, I just forgot this parentheses. And now if I print the number of parameters, let me just copy this and put it here, and you can see now the total parameters should be the same, but the trainable parameters will be 0 because I have add this this freezing. So parameters requires gradient is equal false. Now let me just create another variable, model transfer learning is equal model. You just need to save it in another variable so I can save the model as it is once I have changed anything. So now number of features is equal model dot fully connected dot input layer, input features, and let's see, print. You can just print number of features. Num of features. Now we need to update our classifier. So we will see model transfer learning dot fully connected layers. Okay, then we will need this linear number of features, and the output should be, let's see, 10 classes. So now we have a different output classes. We will see how to print the number of classes and etc. So let me just run this, and you have seen transfer classes, number of classes. Let me just create another one. This is markdown. Let's see just a code, and let me copy this. What you expect to have a number of classes, and what you expect how many total number of features, and also the trainable parameters. So you can see number of classes is 10, and total number of features, total number of parameters will be less. One. If you see, it's this number of features. It almost minus 50,000 parameters. So we reduce the model with 50,000 parameters, and the number of trainable parameters will be 5,000. And in the one of our videos, how to calculate the number of parameters, I have explained how to calculate the number of parameters in the CNN. So if you have any question, please drop a comment, drop a question in the comment below. I'll try to answer. So now we can see this is the transfer the new model. Now we need to add the classifier. So not the classifier. We have already did the classifier here. Now we need to train this classifier on our data. And let's see. In the beginning, you need criteria. Let's find criteria. It's equal. You need to use cross entropy loss. You also need optimize is equal opti dot Adam. We need to update the model, the parameters of this model, the transfer learning. Fully connected, then parameters. We need only to update only this part of the. Then the learning rate, it's fine to see it like this. should be already imported here. This one. Optimizer, Adam. Okay, where's this? We have seen this. Freeze optimizer got an empty parameter list. And the error is here. We have added the parameters and the learning rate. Sometimes you need to use the parameter name, but that's not helping. So let me check. Okay, this only this parentheses just solving the issue. As you can see here, I have the error. I just forgot to add this one here, so it should work now. So now we need to C4 ebooks. Number of ebooks, let's see, in a range of 100. Let's see. And you need to calculate running loss is equals 0. And now we need to go through our dataset. For we need in images, then the label n train loader. We also need to put these images in a to in a device to device, and we also need to put also the model. Yeah, don't forget to put this. If you put the model, the images in a device and the models in another device, it won't be work. So please make sure that model transfer learning is equal model transfer learning dot to, then we need to put it device equal device. So because this is needed indeed, otherwise if the image is in a different CPU or GPU and the model in a different GPU, it won't work. So the model and images have to be in the same device. Okay, so optimizer. So we have defined the optimizer here. Adam transferred. Indeed, in the beginning to have it as 0 to reset, then output it will be model and images, and the images, you see, it will be in the train loader. It will be resized, converted to a tensor, and also use the normalization, or let's use standardization, and this is the right way, the right name, because you can see here, because the normalization, the the loader will use the transform, and the transform has this stuff. Okay, so we're almost done. Now we have to calculate the loss, and we need criteria label, compare the label with output, and this will calculate the loss. And now we need to have a loss dot backward to update the weights, and optimizer dot step, and let's calculate the running loss is equal loss dot item, and here for each ebook you need to print for instance ebook. Let's have use this one here, and ebook is ebook, and out of, you can see because it's only 100, you can see here number of ebooks is equal 100, and change it here to ebooks. If you want to, let's see, to make it more efficient, out of ebooks. So this is the training model. So now this will use the ResNet model with the after the freezing the layers, and train the model only with these few parameters, with this here, and only for our small data set. And I think that's it for today. And if you like the video, please subscribe into my channel, like the video, and if you have of course any question, drop it down in the comment below. I will answer it. And thanks for watching, and happy learning. Bye bye.